Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at, of course, a branch in geometry. We had looked in our first video of some aspects of geometry and introduction to what geometry is. We looked at different aspects of points, a line, segment, and then we talked slightly about a number line. So today we're going to look at a subtopic, of course, in geometry again, that is dealing with rays, angles, and planes. Of course, it will be an introductory topic, as I said, and then we shall look at each subtopic in details in our subsequent videos that we're going to do. So without further ado, thank you and welcome. So as I said, today we're going to look at a branch of geometry that is part of mathematics, but basically we're going to narrow ourselves to the topic of dealing with rays, angles, and planes. And as I said, this is fundamentally an introductory part of this part of geometry. And before we go that, of course, it will be important for us to try and have a small recap of what we have discussed, so that it will give us a footing on how we start this. So for that case, we said that this part being part of geometry, and we said that geometry is a branch of mathematics that deals with measurements, properties, and relationships of points, lines, angles, and surfaces and solids. So in that case, we said that this one deals with it's a branch of mathematics that deals with the measurements and properties and relationships of points, lines, and then we talked about angles, surfaces, and solids. So in that case, in our first video, we had talked about points, line segments, but we never talked about angles and maybe surfaces and solids. So in that case, as we are proceeding in that order, we're going to look on how these two concepts that we have discussed are going to have an interplay in the other remaining ones. And perhaps we're going to introduce new concepts like the rays that are written here. So without going into details of those, let's just try to look at what we are discussing today. So as we have had a recap on what the definition of geometry is, we have seen on how this, of course, that subtopic that I've mentioned is going to be part of that. So as we said, a point like that, we're given an example of that, and we say that a point is an infinitesimally small single location in space that has no length, width, height, but only a location. So suppose this is just an arbitrary section in space, and I said that we defined a point as a very small. Infinitesimally means that it's a very small single location in space with no length, height, width, but only just a location. So in that case, we developed from a point and said that suppose we have point, this is P and Q, and then the shortest distance between P and Q is what we refer to as a line segment. And then we said that this line segment, if it continues infinitely on both sides, this is Q, this is P. So if there's a continuation from point P infinitely and point Q infinitely on both directions, then we can call this one a line. So in that case, we're going to see how that one is going to develop from a line onwards. So from that concept of a line, then we can say that number one, we had a point, which is that one. And then number two, we talked about a segment, which of course for us we denoted as moving from point. The points P and Q, we gave them more arbitrary points, so as well we can just use different letters of the alphabet so long as it's denoting those 2 points. So in this case, This segment we said can be denoted as AB. So this is a segment. And then in that case, we talked about a line being now a continuous part of course, which extends infinitely from both directions of A and B. So this is the gradual development from a point to a line. So there's this other concept that I want to introduce now that we have discussed, the three, which is array. So we are going to look at what array is. Now array is part of a line. The array starts at some point and extends infinitely in one direction. Now, as we have said that a line extends from a line extends from a segment AB infinitely in both directions. Now, for array, it extends from a point infinitely towards a single direction, but not both direction of a segment that we have put AB. So in that case, suppose we have maybe the points. We said we can just allocate endpoints of the alphabet. So suppose we have points like K and L, alphabetical numbers, and this is a point from point A to L, and it is extending infinitely in one direction, then that one can be referred to as array, and we denote that one by writing KL and that small arrow over there, indicating the direction of extension, of course. So when we are presenting an array like that, of course we are going to see that it's very specific on direction. And let's say there's another array that is traveling, or that has been indicated in the opposite direction, but it still that contains the points K and L. Then this one, of course, this is a denotation for the first one, which is this. And then for the second one that we have drawn, it's going to be denoted as LK. So if you try to look at the difference between the two, is that the arrow points to the direction of travel, and therefore we can look at this and say that if we write and say that KL, this is a line, is equals LK. Of course, we are going to talk about scalars and vectors, where we are going to denote magnitude and direction. And now when we are indicating a direction, in this case, of course, the arrow you can see that I've used here is just different from the line that I've indicated here is different from the arrow that I've put here. So this one, as I said, this one denotes a line segment. So in this case, if we try to refer to the line segments, this is for KL and KL or LK. The magnitude of the line segments can be represented as this, and we're going to talk about commutative property. But in this case, if we're not having a vector which is indicating direction, then these line segments are just the same, and they can be represented as such. But in case we were to represent it using, of course, that ray, which is indicated using that arrow, then we cannot use this arrow and say that it's equivalent to that one because of the aspect of direction. So we cannot say that that one is equivalent, this ray is equivalent to that segment. So this one, of course, is going to show an inequality between the two. So the first one that we indicated using the segments can be the same, but for this, when they have changed direction, it's not just the same. And in any case, this is a segment and this is a ray, so they're not going to be the same. So in that case, when we say that this is an array, of course, we have defined what array is one that runs from a point, or this line segment that extends from one part of the segment infinitely in one direction. So from array, we are going to see that the combination of two rays form what we call angles, or an angle. So from this concept, we are going to move to that one, which is the concept of an angle. Now, an angle can be defined as the one consisting of two rays consists of two rays that have a common point such as the one that we're going to demonstrate. So in short, an angle is of course an angle is going to be maybe a combination of two rays that have a common point. We're going to see that one in terms of maybe measurements. So in this case, just simply we can say that an angle consists of two rays that have a common point. So as we're going to draw, we're going to use these aspects of segments and rays in order to have a broader definition of what an angle is. But in that case, it consists of two rays that have got a common point. So suppose I have array PQ. Of course, now that we have shown that we're indicating them like that to show the line of travel from one point to the other one, it continues infinitely. And there's another one that is from point P to R, getting using that. So in this case, we're going to see that the letters that have been used to denote these two rays have got a common letter P. So in that case, as we have defined an angle as to consist of two rays that have a common point, then our common point is going to be P. Therefore, we can have the first ray like that, and the second one like that. Of course, this is a common point P. We're going to talk about a point of conjunction, or maybe the point at which they are going to cross one another. But in this case, because we said they start from a point and continue infinitely in the single direction, so it's going to be a point of origin. So in that case, that is PQ. This ray is traveling from P to Q as indicated by the arrow, so that is PQ. And then we have another one, PR. So from point R, it continues infinitely in that direction. So in that case, we can say that this is line PQ using that arrow, and this is line PR using that arrow. Now the extension, or the space that has been formed due to the joining of those two rays is what we call an angle. So this is what we call an angle, and it is denoted using the symbol like this. So that one denotes what we call an angle. So in that case, I'm just trying to put it like this so that to show that it's the sign that it denotes, or that gives a notation of an angle is given by that. So in that case, this point of that angle is going to be called a vertex. That is a common point that we have talked about, where the two arrows originate from, is going to be called a vertex. Now in that case, since we have said that we're going to give it using that notation, then we can use, of course, these two rays that we have given to give a notation also for giving the angle that has been formed in between there. So in that case, we are going to denote that angle that has been formed using this particular set of format. So we're going to say angle P, angle QPR, or angle RPQ. So this is angle QPR or angle RPQ. So in that case, as we have said that we are going to denote or give it a notation, that notation starts in front of those, of course, combination of letters. So in that case, we're going to see also that the vertex, which is point P, whenever we are denoting an angle, the vertex lies in between those letters that we have talked about. It's our common point P. So that's how we denote angles when we are talking about the junction of two rays that have come together. So in that case, I hope that the introduction of an angle has been shown in this demonstration. So whenever maybe we're going to give these letters to denote an angle, maybe in mathematics or physics or another aspect that may require that, this one will give us a clear picture as from the point, the line, the rays, and then the angle. So we shall move next and try to define what a plane is. So next we shall look at a plane. So as we have talked about a point, a segment, a line, an angle, ray, and an angle. So now there's a concept of a plane, of course, which I'm just going to demonstrate using this particular set of just a drawing of lines. So just use this. So this one I'm just drawing it in two-dimensional space. That's trying to show a flat surface. So suppose this is a sheet of flat metal maybe that is covering this area. Then the surface or the region on that is what we call a plane. This whole region that makes up the mess is covered in what we call a plane. So by definition, a plane is a large flat region that goes infinitely in the four directions. So in that case, you can see that this one can go this and opposite that one, and in this direction. So by definition, a plane is a large region, flat region that goes infinitely four directions, as I've indicated. Maybe we can just even use maybe it's right, left, up and down, or maybe north, south, east and west. So it's a large flat surface that goes infinitely in four directions, and in geometry it is represented as such that the way that we have drawn. But since we just have to show it, we have to have a limitation. So that is why I've just put the boundary in white. But as we have said that it extends infinitely now for the sake of just representation and geometry, that's why we have put it to have a limit of the boundaries that we have shown that one. So in that case, a plane is a large flat surface that goes infinitely in the four directions. So that's as simple as that. So we shall also move to another concept that we're going to discuss, which is going to be very important for us, of course, which is about, now that we have talked about angles, rays and angles, planes, we can extend our concept and talk about measuring angles. Perpendiculars. So as we have said that an angle is junction of rays that start from a common point, we can be able to measure the degree at which these rays just maybe extend from one another, or the degree at which they are closer to one another. Or in that case, it's about measuring the magnitude of that angle. So in that case, if we say about measuring angles and perpendiculars, now a perpendicular is a line that joins another one at an angle. Now that I can just maybe for a little bit ahead, but of course you can just mention it. A perpendicular is a line that meets another line at an angle of 90 degrees. So we can say that if this is line AB and this at point OP, then we can say that line OP meets line AB at 90 degrees. So therefore we can say that line OP is perpendicular to line AB. So that's the concept of perpendiculars that we are talking about there. But now that we are going to look at the aspect of measuring angles, that one just I've mentioned it forehead. But let's look at this. We talked about a line that extends infinitely, but still we can measure the magnitude of that line using maybe different units. It can be kilometers, meters, centimeters, etc. So suppose we want to measure this line. Of course we can use a meter rule, standard meter rule, or just a tape measure. So in that case, when we are trying to measure a line, we measure it from this point of P to Q by bringing this point Q to ensure that it coincides with the 0 mark on the measuring tool, and then we can be able to read the extent to which it extends from this 0 mark to that point Q. So that will be the measurement or the magnitude or the size of the line from P to Q. So for that case, in measuring lines, the length of lines, that will be as simple as that. So maybe it does not necessarily need to coincide with the point 0. Suppose this one was at point 6 and the last one was at point 15. And the magnitude of that line, which is PQ, will be 15 minus 6, and that one will give us 9, of course. So that one will be 9 units. Can be, I said it can be units, of course. If it's a B, it's a very large line or a distance, it can be units of kilometers, meters, centimeters. If it's smaller, millimeters, it is still smaller than that. So in that case, for angles, we use a different kind of a procedure to try and measure these angles that I've talked about 90 degrees. So for angles, we use a different kind of rules. Now this is the concept of using, of course, what we call an instrument that is known as a protractor, but it uses the concept of a circle whereby the units of measurement for angles is defined in degrees. Now this one measurement will be taken from a line. Of course, we said this is a circumference. The line that is continuous around a circle, the length of that line is known as the circumference. This is this length, of course. Can start from another point. So in that case, this second line that is from, maybe I say from point O to P, is known as a diameter. Or maybe I can just say from point P to Q is a diameter. And if this is point O, then angles are measured from this point, in that this line coincides with the line of the measuring instrument that we call a protractor. Of course, it's a geometrical kind of a tool that is used to measure angles. So you bring a protractor and put the line, the horizontal line, to coincide with this, in that the 0 mark for measurement of angles starts at that point, and we measure that. We can either measure them in the clockwise or anti-clockwise direction, depending on what we are trying to measure. So in that case, for a protractor, it has got a set of units that run from 0 to 180 equal units, and 1 unit is equivalent to 1 degree. So in that case, if we were to measure 2 rays using a protractor, suppose this is ray OP that continues infinitely in that direction, and there's another one that is OQ that continues in that direction, and we needed to measure this angle in between. We'll just bring our protractor and place it, of course, on this. I say that protractor is a semicircular geometrical tool, so I'll just bring the protractor, place it on this line, in that the horizontal line for the protractor lies across this line of a diameter, and then the 0 mark, since it is calibrated on both sides, the 0 mark will start from that point, and I'll measure anti-clockwise up to this point whereby the line OP extends. So I'll measure the line here and take a reading from the protractor of the extent to which these lines, this ray OP has deviated from OQ. And then the measure in between here will be the measurement of the degrees, of course, which I'm going to take from that kind of measurements. So rays can extend to different degrees, of course, ranging from 0. I said that for the protractor it ends at 180 degrees, but some angles can still extend and go beyond that. So there's a name that we are going to use to refer to that angle. Or in any case, if we are trying to measure an angle of this kind, then we can be told that this angle extends maybe from here to this other point. So in that case, there will be an alternative angle that is on that side, but the whole of that circle contains 360 degrees. 360 degrees. So in that case, the semicircular one for the protractor, that's 180. So we can be guided to maybe measure angles from this other side, whether they are more than 180 or less. That's according to the instruction that maybe we are required to use as a guideline. So in that case, that's how we perform measurement of angles. And as we have said, we have given a denotation or the way in which we are going to denote angles. So let's look at another concept. Of course, now that we have understood about what perpendiculars are, and we say that a perpendicular is a line, it's a junction between two lines which have formed 90 degrees. So those two respective lines, like the one I had given for demonstration, are perpendicular to one another. So whenever two rays come together, of course, I've said there are different extents to which the line is going to deviate or open from one another. It can form different kinds of angles, or just different types of angles are going to be formed between these two rays which have a common point. So the first, we're just going to look at a few because there are a range of them. The first one is known as an acute angle. An acute angle. So this is an angle that is measuring less than 90 degrees. An acute angle is an angle that is measuring less than 90 degrees. So when we shall be mentioning during our discussions that this is an acute angle, we'll be having an idea what an acute angle is. So number 2, we have another example that is known as an obtuse angle. Of course, for this is an angle that is greater than 90 degrees. So it will be measuring more than 90 degrees. In that case, we shall have another one which is a right angle. So this is an angle that measures 90 degrees. So this is an angle that measures 90 degrees. Now, for each of these 3 sets of angles that we have talked about, we have different notations. Now that we said the common notation for getting angles was that for these three sets of angles that we have said about acute, obtuse, and right angle, they also have different notations in which they can be able to be illustrated. So we are going to look into that one for summary. So for acute angles, they are less than 90 degrees and they are indicated as such. So this is from this point, measurement from this point, they are less than 90 degrees. And then for obtuse angles, as we said, they are more than 90 degrees. And for right angles, they are just denoted as such, and they're usually 90 degrees. So in that case, with reference to 90 degrees that we have talked about, we can be able to define acute, obtuse, and right angles. So that is for the case of measuring angles that we have talked about. And we said that for perpendiculars, we denote them as so of course, just to give us a short demonstration. For that one, of course, we have discussed about perpendiculars at the beginning of this subtopic, but I'm just going to give just a small demonstration of what we talked about and how we can be able to denote them. So suppose we have two lines which are running like this, and then from this point P, we have Q, and then we have got point R. These are two rays that are running infinitely from point Q, and then this angle is 90 degrees. Therefore, we are going to denote that the ray PQ that is traveling in that direction, PQ is perpendicular to PR. Of course, we say that when we write like this, the P is the common point. And that is basically, or in a simpler way, how we denote perpendicular lines. So if we come across this relationship in our books, or maybe in our discussions, we are able to note that those are perpendicular lines. So let's look at another concept that is known as congruence. Now in this case, congruence deals with the sizes and shapes. Of now these figures, so that now that we have defined points, line segments, lines, rays, angles, and planes in a summary, we're going to look at another concept that's known as congruency. Now, if we have maybe two line segments, that is AB, that is from this point to this, and then we have another line CD, another line CD running from that point to that one. If the two segments are equal, then we can see, or maybe we can just denote the two segments as segment AB and CD. And if the two segments are equal, then we can say that AB, segment AB and segment CD are congruent. So if the two segments are equal, then we're going to say that the segment AB and CD are congruent. And there's a symbol that we use to denote that. So we use this symbol that has got symbol like an equal sign, but there's another with lines over there. Now in that case, when we come across the relationship that has been given using that symbol, then we're going to note that that symbol represents congruence. So when we're saying AB is congruent to CD, that is the symbol that we are going to use to denote that. So in this case, it's not only segments that can be congruent, but as well angles, triangles, polygons. In this case, of course, angles, now that we have referred to them, so angles, triangles, polygons can be congruent. Now in summary, we have just defined what angles are. It's a junction of two rays. So for triangles, try from the prefix, try this is a three-sided figure, can be piece, etc. For polygons, poly means many, of course, more than, can be more than three. Can be more than three for maybe a hexagon, polygon, maybe heptagon, octagon, etc. Those are the prefixes that are being used for to denote, like the octa, this is an 8-sided figure, and then for the pentagon, penta, this is a 5-sided figure, etc. So we say that angles, triangles, polygons, etc. can be congruent in that case. So as we are going to discuss also, remember the aspect of congruency refers to equality of what we've discussed, and we have given the denotation for that. So we are going to have a discussion, of course, other aspects of this in details when we come across them. So in that case, thank you guys. This was of course an introductory topic to some of these areas that we have discussed. Of course, we are going to look when we are just going to allocate specific measurements for angles and these other polygons in order to determine which one is congruent or not, or the lines which, of course, the rays which meet at the same specific angles. We're going to define them in terms of maybe obtuse right angle or acute angle when we come across examples, or for the examples that we're going to solve in our problem solving practices, we're going to use the same concept. So for that case, that's where we're going to stop. Thank you. God bless you. Bye.